All right, excellent. So, in theory, today, I'm going to start working on a new type of game, which I've not attempted before, and I think it's going to be pretty good fun. We're gonna try and figure out how to make a colony simulator. So this will be a game like, I guess, a Dwarf Fortress and Stone Half, the new one that I was playing, The Wandering Village, Rimworld, uh, Medieval something or other, and they all share a lot of common concepts. So you've got tasks, which can be literally anything: building something, placing stuff, growing crops, and moving things, whatever it entails. And then you've got things like their health, food, water, sleep, conditions, various afflictions and stuff. And then some of them, like, I don't know, oh no, I can't remember what it's called. Something with regards to oxygen. Oh, I've watched hundreds of videos on it as well. Oxygen not included, that's the one. So yeah, the idea will be to make something, at least the system, right? I'm not gonna go too far into it and make like the whole game from scratch. I might work on it more in the future or something because it would be really cool to actually see it working. Um, but for the most part, I want to make sure that I can load the Unreal Engine with generic models and stuff and say, have some guys in there, and then you just say, build this here, and they gather the right resources, they drop them off, they eat when they need to, drink when they need to, sleep when they need to. Even like the personality side of it, where they have likes and dislikes and happiness. Um, so yeah, my plan is to figure out the framework for something like that. And as usual, it will be a C++, Unreal Engine 5 project, and it will all be publicly available as well. So when whatever I'm currently working on will be accessible for everyone. So that'll be cool. That's the plan anyway. And I'm going to approach it this time going from how you actually go from almost like a literal textual description of what you're aiming to do to UML, which is what you can see in front of me at the moment. This is called Enterprise Architect, and it's specifically designed for making software systems. So I'll get onto that in a bit. And Word, because words how I'm gonna keep track of all of the sort of all of the ideas, all of the aspects of it we need to cover, and then we can go from the literal text descriptions to UML, and then we can use the UML to generate. Well, we won't actually be using it to generate the code, but in theory, you can straight up generate C++ classes, Java, Python, whatever language it is. For the most part, you can actually export, generate code, import code. It can reverse engineer the existing code as well into class diagrams and things. Anyway, so in order to get started, we need to actually come up with the systems and stuff. And this is going to be a really free form, bullet pointy sort of Word document, basically. So it's something a bit more reasonable. Cool. So as an example, we're going to have hunger, thirst, sleep. We're going to want to have tasks, So I'm just spitballing things that these games usually have. We've got personalities, obviously there's resources. The idea of well, obviously you've got workers, and leave it as that. I can't think of anything too significant. So we need to come up with some rules and stuff for how the game is going to work, what's involved, the interactions between all of these systems. So, for instance, workers will have priority tasks. So now we know that workers have a connection to tasks, and tasks therefore have the concept of a priority, or at least the worker's relationship to the tasks has a priority. Workers will also have, I mean, I could probably just move these down to here. So they have hunger first, sleep, steps, and then so we have this task system. So we essentially want so tasks so tasks can have priorities. Tasks will have like a collection of actions. So let's say, for example, you say this worker needs to build this particular structure, or a better way to look at it would be this task requires these materials and these workers are available to complete it. So when you create a task, the workers, when they figure out that that's a task that they need to do now, they will generate a list of actions that in order to achieve that task, which will be like an ordered list of actions to complete. So if you're making a building, normally, speaking in these games, you'll have physical resources that exist in a location, and then they'll have to move to the resources, pick up an amount of the resources. Usually, workers will have like a carry capacity, so they have a limit to how many they can pick up. Then they obviously have to move to the location, drop off the resources, and I could go on, but you get the point. So we need workers will have actions. So they have actions in order to complete tasks. Tasks can be done by workers, so you can have, in essence, infinite people contributing to a task. Now, there's going to be an interesting I don't know, that's a weird way of wording it, but whatever. So one of the key aspects of this that we want to avoid having problems with is when you have a worker, multiple workers contributing to a singular task, and as one of them completes an aspect of that task, the others will obviously need to respond to that and reassess what actions they need to take. So you can have one worker who assigns themselves to picking up wood, and let's say, for example, they can complete that entire aspect of that task. so they can, they have the right carry capacity to hold the amount of wood and stuff. That means that that part of the task can be marked as complete as soon as the worker attempts to do it, or like in progress. So we've got actions, the in progress blocked completed. So this will be similar to almost like a quest system, right? I don't know. Okay, whatever. I don't know why this is being like that. Oh, okay, hang on. Gone to a weird font. There we go. For some reason the text size is I'm making this horrible now. Right, so we definitely need a system that can cope with multiple people working on it at the same time, and then that will allow in document space. Colony, yeah. Okay, so that will allow us to control the outcomes of tasks and keep a close eye on everything that's happening. I don't know why these are all so different. Anyway, so so this also means that actions can be completed by multiple workers as well. So let's commandeer this. So in order to achieve something like this, we're going to need a quite significant event-driven system. So the workers and the tasks manager, or whatever it will end up being, will need a very solid sort of line of communication to be constantly kept aware of what's going on. So we have tasks that can be going on all at the same time. So let's say we have a building, there's like 10 wood available, it needs 15. So the action that the workers, and let's say workers can then carry 5 at a time. So one worker will pick up the fact that this task has an action of carry wood or deliver wood or something. So he'll figure out that he can carry 5. So the action triggers, sends an event. All the workers go, oh, I can do this. And so the first is kind of a first come, first serve basis. So the first worker will take 5 from the wood. The next one does the same. And then the action can change to an in progress state. And then the following workers just go, oh, okay, it's like completely assigned to, so the other workers have already taken up that task. And then the next action could be like it needs stone, so the same thing happens again. But if, for instance, there wasn't any wood available at all, but there were I know, for instance, workers with tasks for cutting down trees, those workers could, like that, and the task had a high priority, that suddenly the priority of cutting the trees becomes equal to that task priority. So that could be an interesting thing. I don't think many games do that, and it's definitely something I've had issues with in the past. So if I feel like I should probably have pulled up a drawing tool or something to give examples of this. But so let's think of it like this. So tasks can have priorities. So if somebody's got, so workers can have jobs as well. So this is going to be interesting. Um, so let's say we've got a woodcutter. His sole priority is basically, in order, will be like first, hunger, sleep, work, or something to that effect. So if I don't know, let's go down here. So we've got forester job. I really want to do something different with these there, right? My spelling is atrocious and I'm very sorry for this, right? So generally speaking, so they're gonna go with first, then food, then sleep, and then their job. So say for example, let's think, because they're going to be constantly cutting trees down. But let's say there was another task that came in, and it was high priority. So okay, let's say they also. I can't think of a good example of this. Okay, let's think of just job priorities in general. Actually, no. Okay, global priorities, right? This is going to be for all of them in general. So these are going to be non-negotiable, right? So you can't change first, food, or sleep. Then there's going to be, let's say there's a priority that's like, do it now, because games that don't have that, really, it gets really difficult to get people to ignore drop everything they're doing and do that. So then they'll have their normal job, but then there's going to be like, subtle actions involved in here. So if their job's cutting trees and you had somebody else gathering the wood for another task, then they'd probably just carry on. But if they're the only person available, so if nobody else can take on their job, and let's say there's tasks a higher priority than their job. So if a task comes in that no one else can fulfill, so a good example would be you've got 5 people and 4 of them are asleep, and there's a task that needs to be done. So this person will go ahead and go and fulfill that task, be it like carrying resources to a building or something. But if we have an action which would be wood for that requires wood as part of that task, and their job was the ability to was to cut trees down, then they would instinctively go and do their job because that action is blocked. But it would be like a higher priority. It would be a sort of on par with the do it now part of the task, I suppose. I don't know, something to think about. I've gone off gone off on a tangent a bit there. Anyway, so yeah, so this system, this is the significant thing. This is going to be difficult to. Actually, let's put that back in. So this is going to be difficult to manage, but put in like a 1 to 5 and do it now. So concept. So there's all of that. We've got resources. I mean, we can just come up with like wood, stone, come up with some basics. Don't know, wheat for food, apples, berries. I'm just gonna spitball some food and things like water. saplings for trees. That'll probably do for now. We can cover most of the basics at least. So yeah, so we've got the concept, things that workers have, things they can do. Oh, I don't know. Something like that. Don't know why it didn't have a problem with that. Oh yeah, this is part of workers as well. There we go. Okay, so yeah, they've got hunger, thirst, sleep. They have a carry capacity. They have a job. They can have personalities. So all this is an idea. We've got tasks. Tasks have priorities. Multiple workers can contribute to a task. Task has various actions. So standardly, it will be an action for each type of resource that contributes to it. And then there will be an action for the actual construction of the building. And then once it's done, obviously it's done. There could probably be one for let me think. So we're gonna have a yeah, that looks horribly spelled. Oh, collect resource, something like that. Construct structure. Remove blocking. Obstruct. Something like that. So in the Wandering Village, it has a really nice feature where if you make a building on top of resources, they'll just go ahead and gather it, which is quite useful. So there's that idea. That should be pretty basic. And then obviously people's jobs. So if we make a overall one for jobs. So it would cost the double team. It is. Farmer. Don't know. That will probably do for now because he's gonna get a little tricky. So the AI controlling the individual people will manage most of this. The actual statistics, like the actual raw data for this, will be stored in the actual character class. So then, yeah, we need a concept of jobs. The jobs will dictate priorities for that particular individual. So then what we've got down here is, of course, all of this. So when you get a job, you still need to drink, eat, sleep. You prioritize do it now tasks. Tasks, I'm going to say that the tasks that only that worker can complete, and then their raw job. I'm also going to put something that's like an alert state. So this is the idea where you kind of like a combat state, I suppose, where they will go and return to a central location or something. I'm not sure if combat's going to be in this or not, but it would be worth considering it, at least putting it in and then not using it or something. Yeah, so we got pretty much the basic idea of what we want to achieve with this. So basically we're going to go attempt to design this in UML. So this is going to be generating classes, structures, enumerations, maybe even interfaces if I can think that far ahead. So I guess I need to explain UML now, which is good because it's the kind of thing that you probably ought to be able to do if you're doing software design in any capacity, because it can make a significant impact on the outcome. Basically, you can foresee problems before they even happen. I mean, even just talking about this, I've come up with some stuff that I hadn't considered prior to thinking about doing this. So, all this kind of stuff. It's the kind of thing that you probably think you've got it all okay in your head, and then when you come to actually do all the logic and stuff, you're like, oh, that doesn't make any sense. This can't work with this in this situation or something. Anyway, so I'm gonna go to this. So this is a application called Enterprise Architect. It's a fairly industry focused application. There is very limited sort of explanation, and it has so much stuff that if you've never experienced this before, it will be quite significant. I'm not saying at all that people should go and get this, because what I'm about to do, you can basically do in an Excel spreadsheet or Visio, or hell, you could do it in Paint or Post-it notes. That's kind of the point of this. The only reason I'm doing it in this is because I already have it, so I might as well make use of it. But you can very easily go and do this sort of stuff in Word, making class diagrams and sequence diagrams and stuff. So the idea of UML, which is Unified Modeling Language, is to create a visual representation of a system in a manner that most people with a limited amount of explanation could understand how your system, what your system has and what it's trying to do, not necessarily how it works. That's like looking at the actual code and stuff. This is more the interactions and stuff that your system has, and what it's capable of, and all that kind of stuff. So in order to do this, there's a really easy approach to this, which is essentially you go from, I could waffle away and write paragraphs of text and how it all works and stuff, and generally you'll get a requirement from a customer or something that says, oh, we need a system that does this, and that. And so what you generally tend to do is any nouns like task, action, resource, structure, and then are basically your classes or attributes, variables and stuff. And then any verbs are usually operations. So, for instance, got this concept of collect resources. That's probably going to be an operation on one of the jobs, or just a base worker. There's a type of action. So the idea of prioritizing tasks, they'll have like a current priority and stuff. They'll have a running list of things they need to do. So they perform actions. So the worker would probably have an operation called perform action, which takes in an object of type action. And then inside the AI, obviously, you work out what that actually entails, be it move to a location or gather something, all that kind of stuff. So, in UML, we create a diagram, class diagram. And a class diagram is a view of your classes and how they relate to each other. So if I can find a existing example, and I'll look through. I will just go through here a sec. Probably in here. Oh no, that's. Have I put it in one of these? Sometimes I do. Sometimes I do this for my other projects, believe it or not. No, probably not. Okay. I've definitely got them somewhere. It's probably here. That's a bit different, I suppose. Just open this. See what one this is. Okay, there's not much to it. Alright, don't worry about it then. I will carry on in here. I have examples from old projects and stuff that are a bit more in depth and will probably be a bit easier to visualize, I suppose. No, not even in there. Okay. So, the obvious thing here is we're working in the Unreal Engine, so there's a few common classes that we probably ought to create. So create a class. So you have the name of the class. So in this case, we want a character. So in the Unreal Engine, all of the actor classes have prefix. Yeah, prefix of A. So you got this idea of a character. We're not going to give it anything else because it's not particularly important at the moment. It's just good to remember where things originate from. Then we're going to have another class, which is a controller. I think it's a controller, yeah. So we'll probably need maybe a actor as well. And this is so we can see the hierarchy of all of our objects, and it can help us see where we may be dependent on something too much or not enough in some cases. So as an example, this is a very common thing. So in the Unreal Engine, the A controller has a relationship to a character, or it's a pawn in specifically, I think. Oh, we actually just one sec. Here's AI controller we need as well. Oh, I am messing this up way too much. I'm sure there's a tool for it somewhere. Anyway, there we go. Let me just. I could have sworn there was tools and you just drag drop, but that's whatever. So we have this AI controller. So for instance, an AI controller. This is something that's a more generic version of inheritance, or how you explain inheritance. So you have generalization and specialization. And if I remember correctly, because I always get these mixed up, a generalization is basically something that is the more basic version of something, and a specialization is something that is something else and more, I think. But I've got it wrong. It's for some reason it's the other way around, and I can never remember why. Or is it? Oh, hang on. So we're saying that is a specialization. Yeah, okay, sorry, I've got it, I said it the right way around, but it's the way you draw it out. So you're basically, the end result is the start of it. So in this instance, an AI controller is a specialization of controller. Anyway, so controller also has a dependency on character. This is a directed association. This is basically saying this has a relationship to this, which means it depends on it. So if we ever design something and let's say we got rid of character from our system, obviously that's going to impact the controller and then presumably the AI controller and anything else that's dependent on it. Likewise, this specialization, there we go. So this stops us, or at least makes us consider the impact of any changes that we do to our system. And in this particular instance, just as an example, it is actually this button here. No. So the controller has, I think this is operations, there we go. So this has something around the lines of it's either get character or get owner or something to that effect, right? And it returns, and this is the power of the advantage of using this. It returns an A character, and now you can see that we have, so thank you, right. So we have, you can see it's got this dividing line, and this is where it starts to be sort of more what I was going to show you later. So you have so you have the title of the class, and then you have operations, and you can also have variables. So we're going to, let's say this has one called character, and then like before you can just go select type a character. So you have, yeah, so you have the class name, variables, and operations. And this is a very quick and easy representation of them. So you can see plus and minus relate to the privacy of it. So the accessibility of it, basically. So you have this, its scope is private. You've got the usual protected and public. So like if we make that public, you can see it's a plus sign. Obviously get owner is a fairly standard getter, so it'd be a public. Oh, that doesn't change that. So it'd be a public accessor for that. But obviously we want to keep the variable character private. Anyway, that's just an example. We're not actually going to be using these, so I'll get rid of them. And then another useful thing, this is why I like setting these up, is if I get rid of controller, so it hasn't actually deleted controller. You can see it's still over here. But now this at the top shows you the inheritance. So it's saying it inherits from controller, which you know it's not in the diagram because it's being shown there instead. So if I then drag that back in, it adds all the relationships because the relationships were never gone. We just removed it from this view of the system, and that's why you would want to use an application like this. So we need another one which will be class U objects. All right. So if we're going to start working on converting this into actual classes that we can then populate with logic, we need to start building up the class structure and stuff. So I'm going to, do I need this at all? No, I don't. Okay, so we want tasks, actions, jobs, and I think that's probably everything for now. So from here, we want to create a new class, specialization, and this is going to be called task. Then we're going to create something else here. Oh, I didn't know you could create. Oh, let's try that. Ah, excellent. Okay. I've not used that before. So we want this to be a specialization. So we want action. These should be called new action and new task. I'll change the other one in a second. New job, maybe. I'm just thinking a job wouldn't necessarily be an instance of a class. It would more likely be a very simple piece of data attached to the character. Okay, let's not add job as that. Blah blah blah. Sure. I mean, that's actually kind of all that we need. I didn't need to use this at all. Okay. It's whatever. Now I know it exists anyway. So all Unreal Engine stuff needs to follow this naming convention. I think it makes it either compile easier or the blueprint system works better with it. Or it's been a while, but it's something like that. We probably won't need new object on here, so we're going to do that. And as you can see, it shows the inheritance. So now what we're going to do is create the idea of a task and action so that we can build this as a concept. Right. So what this means is we need to be able to set up the relationships, create the operations we think it's going to have, the data like the enumerations and everything. So a really quick example would be, do we create, actually no, we would need to create one here. Yeah, let's do it like this. So we're going to create a enumeration directed because it contains this. And then I think I'm doing this wrong again. This, and it should make it so we'd have not started. In progress. Yeah, okay, it's coming up like enumeration. Blocked and complete. Okay. So now you can see we have this. I was called enumeration 1, but this will be action types. So there we go. We now have UAction. We know it has some relationship to action types. So we want to add a operation called it's going to be, it would be called get type. Just keep it simple, and then it's going to return something like that, but this should be action type because it's usually used as a singular. There we go. So we got get type, action type. Now, obviously we want task to have a collection of actions. So we're going to set up a directed association so that we can say that this has a link. And then usually there's this concept called roles or multiplicity or something to that effect. And what we want is to set it so that one action can only ever be associated with one task, but one task can always have one or more actions. And I think it's this way around because it's the relation from the multiplicity is going from the opposite way. So this is the relationship side that action has with task. So it's one to many. The star symbol always represents many. And a task will always have to have an action associated with it. And then an action will always have one. Yeah. So what this is saying, and it's from the direction you read it to the end. So an action has one to many tasks associated with it. Oh, have I done this the opposite way around? Oh, it's been such a long time since I've had to do it actually properly like this before. I think it's an action has one task and a task has one to many actions. Yeah, sorry, it's from the side you read it from, right? There we go. And then, of course, we will want something in task for managing the action. So we'll have, I don't know, let's go into attributes first. So we'll have actions. It's going to be a type of, oh, come on. I think I need to adjust my mouse. Come on. There we go. It's moving a bit slower. All right. Yeah, let's do it like that for now. So we've got a collection of U action. I think this is where we change them. So it's going to be one to many. Okay, so that's basically, so what you can see here is it's saying there's a property called actions of type U action, and it can have one to many, which implies it's an array. So this is a collection, set, or list, however you want to picture it, of actions. Then obviously we would have methods for like get actions and add action, remove action. I'm not going to bother putting those in because they're pretty generic and kind of expected. I'm only doing the other ones as an example, but this would be like action type. I think you can do some use. Actually, let's just check because I think I can just drag. I used to be able to, and on one of the applications I've used, you could just drag the type over the property, and it would set the type to that. Anyway, this is a little annoying having to go into here every time. Cool, there we go. So you can already get the idea here that we're creating all of this sort of initial bare minimum. This is what it needs to have to even exist in the system, to function. We're not even like making this work yet. We're just making it so that we know what we want to have, and we now have a basic, I suppose, sort of a bare minimum representation of what the system has. So we can easily convert this into code, and then we don't have to think about it as much. We don't have to go out of our way to do all of sort of figure this out as we're going. Because if you go from this to code, you spend so much of your time generating classes and adding properties, and then you go, oh, what if this situation comes up? And you rarely end up actually making the framework for stuff, and usually forget things and blah blah blah. Okay, so we've got this as a base concept. So it's got tasks, actions, they've got a type. There's going to be priorities, so we probably ought to have another enumeration. This is going to be a priority. I suppose it would just be like low. Is it possible to? I don't know. Keep it really simple. Low, medium, high. And then this will also have a priority. No, this is interesting. So it's going to be an ordered list of actions, or is it just action? See, this is the kind of thing that gets tricky. So if you think about how this task is structured, so if we make a building, I'm just going to go into here. So in order, so we create task, create the actions. The actions are going to be this is going to be like an optional one. So remove obstructions. It's conditional. Right, so we collect resources, build the structure. Job done, right? The problem is, so if we were to create all of these actions at once, immediately, and we had the same system we have before, then these actions will potentially be started without their, like, for instance, we could potentially start building without the resources. So what we need is a dependency between actions. So we almost, in theory, need something similar to a quest system where, like, you would have a quest log and it would be like, go to this place, gather this, craft this, deliver to this person. Obviously, you have to do those in order, but there's a potential for you to, you could at least attempt to do the other ones before doing the previous, which as a player you might not do, but as an AI we need to build it into their to their logic. So as an example, it's going to, the collect resources could be something like this instead. Whoops. So we got collect wood. Why it's doing all these things. So as an example, so now what we've got is two separate tasks of different resources, and the workers can obviously complete these independent of each other. They're not necessary. They're not linked. They're not meant to be done in an order. So this means we need a way of sort of blocking actions and making them dependent on completion of other tasks, of prior actions. So if we go up here, so now we need this idea of something that can't, like an action that can't be started until another's started. So we need some kind of data to relate to the other actions. It could be an ID, it could be like a type, like an enumeration for the so a sort of, I don't know, maybe even like a built-in priority system on them, because we know they already have we already have this idea of priorities from tasks. So we could say actions have priorities as well. So now we do this. So now we have the ability to prioritize actions. So we could have many actions of different kinds of priority. I do think an enumeration system for priority may not be the best, simply because you can go a lot higher with numbers, and a single task could encompass more than the priorities that we've got available. So an enumeration is inherently a number anyway, but we wouldn't want to have perhaps a literal, like, textual value for them. So I'll change this at some point, perhaps. It will probably do for now. So in this instance, this would be pi yeah. So we've got that. But that's still, so further to this, let's say, for example, now these have been being fulfilled. So we have a worker getting the wood, a worker getting the stone, and so that when it comes to the next worker, he goes, oh, these are all being done by somebody else, I can do this. So it still doesn't solve the problem. And this is why doing it like this is very useful. So we still need a sort of a self-dependency where an action can either trigger another action to be added or is blocked until other actions are completed. So oh wait, this shouldn't be action type, should it? This should be right, see, I've already made a mistake here. This should be action status. Easily done. And we don't actually need to represent that at the moment. So we have the status. So now we want some means of depending on other ones. So we could have this idea of like prerequisite, perhaps. So we have prerequisite actions, which so I suppose if a task is completed, if an action within a task is completed, it could inform other action. The sort of do a trigger an event that the other actions then listen for, and they determine whether or not they're good to go. So it could be built into the action itself when it's created. I think for that we do actually need an action type anyway. So I know we've obviously renamed one of them, but this is going to be another one. So let's give it some basic things. So we want gather. That's going to be different, I suppose. Actually, so let's gather, collect, build. Gather's gonna cover the remove obstacles as well. Then there's collect for that, the build for that. And then is there anything else? I suppose there's so let's think about workers when they're hungry. They have a collect action or possibly gather action. if they're hungry, there's no food, and their job is to collect food. Sorry, to gather food anyway. So they'll obviously, if their immediate priority is to eat, and there's food that exists that can be gathered, but it hasn't been, it could trigger a gather, sort of a move action, a gather action, and then an eat action or something. So this would be, I guess there's eat, there's drink, definitely sleep. Let's see, move. Oh, whoops, mouse. Wow, there we go. Oh man. Let's do the terrible auto layout, shall we? Is it gone? There we go. Layout diagram, neaten, auto route. It tries. It really tries. I don't know why these are all a bit like that. Could easily be a straight line. Anyway. Oh, good grief. Oh, I've forgotten all of the shortcuts. It's not appearance, it's line style. Control Shift A. Oh, right, yeah. Something like that. Cool. Right. I'll pull this across here as well. Okay. So we now have so yeah, we've got tasks, got actions, action types, and then obviously, so when these actions are created, a build action will be blocked initially, so it'll be in the state blocked by the others not being complete. So what will happen is when an action status changes to complete, it will tell all the other actions that that's the case. Obviously, our UI might update, our controllers will be informed, the workers will be informed, etc. And then the other actions get informed. And so the state of the build action will then change to not started, rather than not starter. There we go. And then this will allow actions to be dependent on each other and react accordingly as things change. Yeah. Okay. So yeah, there's going to be a lot of event driven stuff for this system, and we're going to be very dependent on events triggering correctly at the right time. Events failing would cause everything to break. But this is the crux of the system. You know, regardless of what the AI controller and stuff do, if I can press a button on the UI, click on the map, and suddenly it says there's a build action, and then the actions get generated correctly, the AI create their own actions, so just to keep it in line with everything, we do that. Maybe that, please. Thank you. We actually don't need to represent these on here at all. Oh, in fact, wait, what am I doing? We need that. That's the dependency. We don't need that one, and we just need specialization, and this is going to be a worker, a AI, and then delete that relationship right there. That's better. Yeah, so we've got our own AI class. Wonderful. Right, and then we've got character. So if we bring this over here, we don't need actor, but we do need a specialization called worker. And then here's where the fun begins. We want this over here, this over here, this over here. That there. This has a dependency on that. We can get rid of character. And there we go. So we've got a worker can have an action, set of actions. A worker AI has relationships specifically to workers. Yeah, tasks have actions, tasks have priorities, actions have priorities, status types. Yeah, so that's getting somewhere. Okay, so we're gonna need task types as well. Or something to that effect. This is probably going to be structure. I don't really want it to be class. Interface, probably not. Signals, probably not either. I don't think it has a representation for structures, or not that I can remember anyway. Well, let me just see. Try this. This is an old one. Just gonna see if there's a way it finds. Oh, good grief! Welcome to my class model for an old game. Man. Okay. I think this is a test I did a while back. Okay, yeah, so they've got, it's a class, but so you've got this, I think is a stereotype, yeah. So in UML, there's this idea of stereotypes, which can apply a sort of standard. You can use them to do some very clever things, but basically you can enforce certain rules and things with them. But as an example, we're going to go class directed association, and in here we should be able to find structure. Maybe. There we go, struct. And this is going to be task. Like info, name, data, task data. There we go. Okay, so we now have a structure called task data, which will have stuff like its name. These are all going to be public. This will be a string. There'll be an There'll be an F string, of course, because it's Unreal Engine. I think it's a struct. Is that? Yeah, good, right. Yeah, it'll have a name. It will probably have, I don't know, a type or something as well. Do I need to do this though? perhaps, will these have the same concept as actions? I'm just trying to think. There's so one of the advantages of doing stuff like this, what I'm creating here could potentially have shared, have the same data structure that both of these can use. So, as an example, you'll have like the action type assigned to action, but instead it could actually be a type stored on this structure. And then instead of task data, this just could be called, I don't know. It's hard to think of a more generic term for both tasks and actions. Anyway, I won't get into that now because it's pointless. Okay, so right, we have workers, so we want worker data, definitely. I'm gonna create this as a struct as well. So let's just build this up real quick. We're gonna have name. I have a, yeah, okay, so this will be not health statistics. I mean it's stats, isn't it? It's gonna, we want another struct that is sort of their health, hunger, thirst, sleep, and like conditions and stuff they're afflicted with potentially. So an example, so we would have current stats and max stats. This is something I do in a lot of my games. Then we have a directed association again. And let's make this. Oh, I've gone past it. See, I need to do this on the other one as well. This is going to be F worker stats, F worker data, stereotype is going to be struct. We go. Okay, so they've got current and max stats, and these are both going to be worker stats. There we go. So what this means is the data in here, I don't need to create in here current health, max health, current first, max first, all that kind of stuff. There's just two separate structures that have the same values. So this will be health. I wish there was a better way to do that. First, hunger. Oh, cool. Okay. Sleep. Tiredness, maybe. Or actually, let's just call this food. I don't know. It's weird to think of what's the inverse of hunger. It's full, but that doesn't really relate to food. I don't know. I just call this one food, sleep, water. This isn't actually tiredness is a bit better. No, because it needs to build down. It's awakeness, really. I'll think of something more sensible another time. Anyway, so yeah, these can be and they could be integers, so they're probably going to be floats. Because then we can do nice accurate numbers with them and not have to convert. So you can see we've got name. Nope, that's not what I wanted. String. Yeah, so they've got all of that. They also have, oh, sorry, yeah, here we go. So Worker doesn't have actually, no, it probably will. Worker has that. If I pull these down here, pull this up here. So Worker has a relationship to action because it manages the actions. Or does it? Do we need action specifically on a worker? No, because it would be the controller. The worker doesn't actually care about the actions. Yeah, so it'll just be this. So now we have these. This, whatever. Okay. Oh, it's all coming together now. Is that? Oh, probably stop in a bit. Okay, so we're getting there. So I need to come up with basically the next kind of step here would be to come up with scenarios, and then you start building not quite like a flow diagram, but the end result could be a flow diagram. But you basically want a scenario, and then you want to think of all possible problems within that scenario and try and come up with either a solution or at least an answer to it, in terms of like, you're not sure we'll ever encounter this, or this isn't actually a problem, or just we'll let this happen, or something to that effect. And then eventually you have all of these alternate cases where you've got like I've explained in here, where if I hadn't have taken into consideration the priorities of actions, this probably would become a problem very quickly. But then I also needed to make it so that actions are dependent on each other. So now that we've added the idea that actions can relate to themselves, so in this instance we would have a directed association. You can see it's done a nice little link to itself. And we'll have, let's think that we want another class. This is going to be an event. It will probably be U event. And then we'll likely have a specialization, and this will be an action state event. And this will link to an action. Got this nice little loop looking thing here. And so this will have an operation called something like action updated, and its parameters will be event. I'm just thinking, how do we normally approach this? So you'd have a generic event that everything inherits from, so that way you don't need to create multiple methods to handle the events. You'd have an event manager that everything pushes events to. Everything then listens to those to the event manager, but you'd create a event subscription service where, let's say, you would have the actions only need to listen for action events. So in this case, the parameters would still be so it would be the event, which would be of type event, but we would know it was actually a type of, in this case, it'd be an action state event, which we need to change the action. Something like that. And then we would have, like I said before, we'd have some kind of event manager. So we'd have a class. Actually, let's just create a new class because it's going the other way around. So this could be like an event manager, and then it could have something like a enumeration. Sorry, this would have an enumeration called event type. I'm kind of going pretty quickly here, but hopefully you get the idea. So this would be action. This would be, there we get task. So these would be like the subtypes, and then the action would register to the event manager. So we'd have something like register listener, and then the parameters would be view objects. Is this how you do it? This is how I do it in one of the other projects I've been on. Can you do this in the Unreal Engine? If you think about this, yes, probably. It would be an array of objects, and then those objects would it'd be an interface actually. So it'd be like event. Yeah, okay, hang on. Oh, I'm typing this wrong. This would be listener. Sorry about this. Right. This is why you do this, because it just makes it so much easier to visualize all the interactions. So we have an interface. I think in this case it's a realization. You realize an interface, as in implement it. So this would be a event listener, and this would have an operation called something like event I don't know. This is like when the events happen. Oh, why can't I think of this now? It's got to be a generic name. It's just I don't know. How am I having so much trouble with this? It's just that something like event occurred, or event triggered, something to that effect. And then it would have a parameter of the event, which would of course be type event. Okay. Oh, I am. No, that's fine, because we're overriding it. Doesn't return anything. So then this would implement the event triggered. So instead of this would be that. So that would be that. So we'd implement the event triggered, and then this. Interesting. That's pretty cool, actually. I didn't realize. Blah 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 blah. Oh, we were developing the operation, weren't we? Has that just disappeared? Oh well. Okay, so the operation would be something like, well, it would be event triggered. And it would, oh sorry, this would be register event. Being an idiot. Register listener. Listen. Okay, so now we want the ability for things to listen to these events. So now it will take in a listener, which is of type the event listener. And lo and behold, we can now handle, I'll add in the event types in a second, but we can now handle, you can now register an action to the, oh, I've been doing it in the wrong place. I'm an idiot. Oh man, it's one of those days. Register listener, sorry, it should be in here. Event. Sorry, event listener. There we go. Cool. And then what this means is if we shove this around a bit, probably get rid of that for now. Move that over here. Put this somewhere down here. There we go. Then this has a direct association. So now these things can communicate with each other through the event listener. If we wanted to, we could make the worker communicate, listen to events, which it will need to for when the action statuses change. And then the tasks can also register to, it can also be event listeners. I don't know why that's gone that way. Hang on. Oh, I'm doing this wrong. Sorry. They're meant to realize the interface. Realization. There we go. Hey, look. And so now that we've added this event triggered, oh, whoops. We can tick this box because it knows it's an interface, and it will automatically add the method to it. The method is currently incorrect because we need to add some properties to it. So we want to listen to specific types of events. So we want event types. So we probably want to listen to multiple of them. This is going to be one to many. Hang on, let's select something like that, and then this will be obviously event type. I need to change these to be the F event type, probably. I can't remember their structures normally. Is it T or something? Oh, I don't know what the Opera Engine does anymore. Anyway, hopefully you're getting this. So if I delete that, so I don't have to do it again. Realization, yep. Oh, okay, it doesn't work. There we go, right. Let me just do something useful. There's diverge, there we go. Do that a few times. Oh, move it out here. Oh, I saw it a second ago, there we go. You just do it twice. And we can straighten these up a bit. It's nice being able to do this. Wrong one. Oh, it's this, isn't it? There we go. And we want this somewhere there. That can go there. Cool, right. Oh, okay. I'm just gonna put you there. How about that? Cool. Okay, and then I don't know, put these down a bit. Okay, right. Hopefully it's a bit easier to see. I'll zoom in a second once they're all a bit better. Oh, and then task can also be an event listener. Cool. This can probably go over here. And then we can move these. Diagram neaten. Cool. There you see. Right. So there we go. So now we have this event listener. We have register listener. Oh, the register listener also needs the event types. I don't actually. Oh, I've been an idiot again. I keep putting these on the wrong things. Let me do this bit again. Okay, right, round 3. Right, this is fine. We just need the event. Don't care about anything else. That's all that we need, because the event has its own type. Come into here, realization. And this is where we need to do that. So this is a one-to-many, and it is of type event type. There we go. That's much better. So when you register to the event manager, you can tell it what events you want to listen to, and then, for instance, when an action gets complete, so that will be the task, or sorry, that will be the action listening to. So that will be the collect action listening to the presumably the building actor, which is where the resources are going to be dropped off. So we'll have an actor that's got, I suppose, a what would I use for that? I guess we'd probably be an actor with, I can't remember what they're called. A volume, like a sphere or box volume around it that the workers will physically place the resources. And then so the building actor that obviously isn't actually complete will then trigger an event to say that these resources has been placed. The action is then obviously listening to that event. Will then update and say, oh, we've gained 5 wood or something. The action will then go to complete and trigger an event itself of type, event type action, passing in itself. So this will obviously, the action state change will have an action associated with it, which will be of type U action. So then the other actions, which would be, for instance, the build action, which is currently in the state of blocked, will then detect that the state's changed, make sure that all the actions prior to itself have been completed, so there's no more build or collect actions or anything, and then it will set its status to not started, and then obviously in doing so send an action state event changed that the AI is listening for, that then knows that that action can be completed, and it will therefore make the AI decide whether or not they need to perform that action. Then one of them will presumably go and complete that action. Cool. Right. That was intense, and I'm pretty glad I've gone through this actually. Because I think doing UML is kind of important, and hopefully whoever's watching this can actually see the value of it, with the amount of information that I've been able to, the amount of things I've been able to figure out just from designing a diagram. You can see all these really intricate interactions with each other and like dependencies and stuff. But it's not like chaotic, you've got action has quite a lot involved in it, but all it's really has is some enumerations. It can trigger events. In fact, it probably doesn't have that link. No, it does because of event triggered. Sorry. So it can trigger events. It can listen to events. Workers have actions and tasks have actions. So it's not like it's like some classes. In fact, like in the game that I loaded just now, if you look at the class diagram for this monstrosity, it's there. So this is like my first MMO. I think this is just me messing around. So obviously there's a lot, right? This is there's events, there's stats, there's just loads and loads of information in here. And if I were to go back and redo this character class would be nearly barely 10% or so of what it is here. Because I'd make an event system which would get rid of all of these, pretty much. They just wouldn't exist, or they wouldn't need to in the way that they do. All of this information, like groups, its inventory, weapons, energy, health, all of that stuff would be in a data structure just off to the side. And then it would have current and maximum. And just all of that kind of stuff. You can see how easily the inflation of these classes. I mean, look at that. This is the character class, not even the controller, and it's got all of these other objects that it has some kind of dependency on. I'd honestly forgotten how bad it was, because like the controller, it just has a link to a few. So this is the advantage of doing this kind of thing, really. Yeah, because if I do that, auto route still creates an absolute mess. But this game had a lot of good ideas in it, and I actually still use the code as an example for my other plugins in projects, because the C++ was quite generic. Like the quest system's really nice. You have quest rewards and quest objectives, and they obviously it's a little hard to see. What's fan relationships do with this? There we go. So you would have sorry about the lines, let's try and sort that out. So you can see we've got quest objective, and then there's different types of quest objectives. And so it's a really generic system for managing quests. So I could kind of copy and paste the code for the quest system from this game into any other game, and with a few alterations to the actual classes, like the owner here obviously wouldn't be the same, and maybe their event system would be different, but the structure of it would be the same, and it would work in any given situation. So that's another reason for doing this kind of stuff, because we don't have the implementation, we don't have the actual code for these classes. We don't care how they work, we just care what they do, what they are, and that's why doing stuff like this is really useful. And then we'll come on to use cases and things at some point. But I'll do some programming next. At least generate all of these classes and stuff. In fact, I might at least do the generation of the classes not on stream, because that's a bit boring to just watch my computer load, generate, kind of. Yeah, so I'll create the bare, like, raw objects, the raw classes, and then I'll go from there. I'll do that tomorrow or something. Cool. Yeah, again, hope this has been useful. If I'm happy to explain anything further, I'll make all of the code and this completely sort of open, publicly available somewhere. I think you can, yeah, there we go. You can take screenshots and stuff, just a press of a button. It does a really nice job. There you go. Just it does all the right naming stuff, and yeah, I don't know, maybe I should make a Trello for this, because that would be quite good. Then I can have the Trello with links to GitHub and stuff. I'll look into that. Anyway, so yeah, and actually at that point we can even, providing I upkeep the diagram here, I can actually almost show like how the system developed from start to finish over time, which will be quite interesting to see, at least for me anyway. So yeah, cool. I will carry on working on all this. Hopefully. Don't know. Yeah, okay. Cool. Yeah. I will carry on Saturday and try and actually implement some of these things and see how it works. I'm really tired apparently. Oh dear. Cool. All right. Cheers, and yeah, hope this was useful to at least someone. Yeah. All right.